Our next functional group is the aldehyde. An aldehyde is very similar to a ketone in that they both contain a carbonyl group. Now remember, a carbonyl group is simply a carbon atom that is double bonded to an oxygen atom. And the motif looks like this, okay? And the only difference between an aldehyde and a ketone is that this particular carbonyl group in an aldehyde is located on the first carbon in a carbon chain, whereas the ketones, the carbonyl group is often located in the middle and never the first carbon. Let's do a quick picture of a carbonyl group at a first carbon for aldehyde. It may look something like this. And again, all carbon atoms have to have 4 bonds, so the rest is filled with hydrogens. So that is a simple aldehyde. As you may guess, all the ending names of these organic compounds refer to their family name or their functional group name, where the ketones end in O and E, the aldehydes end in Al. So for the particular picture that I just drew here with 3 carbons, that is propane, but we call it propanal. Okay. Now the carbonyl group is polar, which makes aldehyde molecules also polar, which gives them a particularly strong intermolecular force, and which causes a high boiling point. The polar carbonyl group also facilitates in chemical reactions. Because that group is polar, it has the ability to attract certain parts of other molecules, thus making the aldehyde family a very reactive family, which is good for organic synthesis. Okay, let's look at some examples of aldehyde nomenclature. Now, since the carbonyl group is a defining feature of an aldehyde, it makes sense that that feature is automatically assigned carbon number 1. So the aldehyde group takes priority, just like how the other functional group defining features take priority as well. So here's a very, very simple one. This is a 4-carbon chain, 4-carbon aldehyde. The word for 4 is butane. So this is simply butane, but change the ending to Al. This is butanal. Let's look at some with branches. Okay. The rules that you've learned before all stay the same. It's all consistent. Once you recognize this is an aldehyde because of the carbonyl group on the first carbon, assign that number 1 and label the longest chain following it. Once we've identified the longest chain, we name the branches. In this case, there are 3 branches of equal size, and they are all methyls. So we start by labeling where the methyls are. We see one at carbon 4, one at 5, and one at 6. Because there are 3 methyl groups, we use the prefix tri. We follow that with methyl, trimethyl, and then we finish off with the main chain name. In this case, there's 8 carbons, that is oct. So this is 4,5,6 trimethyl octanal. We haven't done a condensed structure in a while, so I'm going to give the next one as a condensed structure. Here is the aldehyde in the first position. CH3. Okay. Here is the first carbon. Here is the second. And remember that the horizontal chain is never always the longest chain. In this case, we will go downwards and see that this is a 5-carbon chain structure. Okay, let's label the branch, and the branch is this guy here, which is located on carbon number 2. So this is 2-methyl pentanal. Okay, let's finish off with 2 more. Just to really get the hang of this, let's throw in some branches that are not methyls. Let's throw in a bromine. Another bromine, and let's throw that one in there again. Okay, so this is carbon 1, because that is where the carbonyl group is. 2, 3, 4, 5, and 6. That is the longest chain we can make. we have two branches, a bromo and an ethyl. We write the branches down by alphabetical order, just like we do since the beginning of the unit. So this is 2, 4. There's 2 bromos, so it's dibromo. 3 ethyl hexanal. And our last one of today. Oops, let's make it a little nicer there. Here we go. Okay. There's no reason why the aldehyde group has to always be located on the right side, so I just shove a little bit, put on the left. So here's 1, 2, 3, 4, 5, 6, 7, and 8 carbons. Here we go. We have 2 branches. We have a methyl and a propyl. Singers of M and O P. M first. So 7 methyl, 4 propyl, and finish it off. This is an 8 carbon system, octanol. Some of you might be questioning, why don't we ever number where the functional group is? For example, back in ketones, we always had a number to say where the carbonyl group is. Well, aldehydes are defined by the fact the carbonyl group is always on position 1. So actually, once we see the letters Al, we know that at carbon 1 there is a carbonyl, so there's no need to write number 1 because that would be redundant. So there we go. Aldehydes, what they are and how they are named. Go out!